Hello, everyone. Today I'm going to talk about using raw data for Zoom SDKs. You will learn the key steps to get raw data from Zoom SDKs in an application and what considerations you should pay attention to use raw data properly. My name is Bruce, developer advocate at Zoom. My job is helping developers adopt Zoom SDKs and realize the full potential of your business with Zoom. First question, what is the raw data? What can we do with raw data? Raw data is the audio and video stream from your session. Zoom SDKs allow you to access those stream data in real time. Access the raw data in real time will unlock you from many interesting use cases. For example, recording video and audio from a session recording video and audio from a session in your own way. You may already have used Zoom recording service, which is awesome. However, if the recording format is not what you want, you can't change it. But you can use raw data to create your own recording, such as separate audio from video for each participant, or create a customized video gallery for your recording. Another interesting use case is adding visual and sound effect. If you are a developer having your own components for processing video and audio, raw data is a way for you to integrate your components into Zoom meetings. Another important use case is to integrate with machine learning, augmented reality, or mixed reality. Raw data opens the door for your Zoom meeting to AI and metaverse. You can detect objects in a meeting or stitch your participants' visual into a virtual world. There are unlimited possibilities to work with raw data in your meeting. Here are lots of exciting use cases. You must be curious how this feature works and what does this look like. Let me show you in a demo. Let's go. Here is my demo screen. You can see your left-hand side is code I created with Zoom Video SDK for C++ on Linux. What it does is to join a session and start to record straight away. In the right-hand side, you can see there's already a Video SDK session created on the screen. I'm already sitting in the video and waving my hands to you. Let me start a demo. Here I input the command Zoom Video SDK Linux bot. This is the name I created for the command line application. Let's run it. Now you can see in the session there will be new participants is actually my application. It starts to recording the video once it's joined the session. You can see in the file system, there's a video file being saved into the folder, and the file is keep refreshing, as well as the file size is increasing. Let me stop the application here. Control C. Then the app stopped and it quits from the session. Let me open the file. You can see the video being recorded as a video file. And you can tell that the resolution and quality is very different from the original video, because when I doing the recording, I encode the file with the third-party components FFmpeg, I use it to scale down the video resolution as well as encode it as a smaller video file. Yeah, this is a very basic use case. In this demo, we actually seeing a Linux application built with Video SDK. What it does is to join a session, read video raw data from a user, and use third-party components. In this case, is FFmpeg to scale down the video and encode the video into a video format, and then save it into the file system. This is a very basic use case. The next question is, where is the raw data in the code, and how can you get it from your application? Here I have the example code here. Just now we shown in the demo screen. I created a class named the class processing raw data To get raw data, you actually need to create a class and implement a certain interface. The interface is called iZoom Video SDK Raw Data Path Delegate. In this interface, you will receive two callback functions. First one is on raw data status change. So in this function, you will see the status of raw data feeding. So one is on or one is off. The next callback function is called on raw data frame received. So this is a key function that you're receiving your raw data. So once a new frame received on your client side, you will receive this callback function with all data as a parameter. So in the data, there are all parameters for the frame you received, include width, height, buffer length, rotation, and source ID. Of course, the frame buffer itself is also being included here. You can use this buffer to process with your own code. So for detail, let me go back to the demo screen. I will show you in my code. Yep, let me enlarge my IDE. Here is the code I'm doing the raw data in my code. So I created a class here named raw data FFmpeg encoder because I used the third-party component FFmpeg to encode a video file. So I created, I give this class this name. Then it implement the interface of iZoom Video SDK raw data pipe delegate. There are two callback functions being received. One is the raw data frame received, and another one is on raw data status changed. Let me see more here in the detail. I also created a few of the function to operate FFmpeg library. FFmpeg library is quite a complicated library. So there's a lot of code. I just wrap them up into a few functions. So some of the functions they are doing starting, as well as some functions doing the filter, as well encode. So these different functions have different usage. Here, the filter, what does filter do is actually scale down the video with the filter from FFmpeg, and then this encode function is to encode the video frame with a codec into a video file. So let me see the detail of when we receive the raw data. Here is the function. Here is the implementation for the function. We should receive the parameter of data, get all the information parameters from the data. There's a width, the height, everything, the rest of the thing. And also below here, I pass the frame buffer data into the function I created for filtering from the FFmpeg. What it does is to scale down the frame into the resolution I need, and then it calls the FFmpeg encode. So another very important function you have to call is here, the subscribe. You have to subscribe a raw data video path from a certain user. If there's multiple participants, means there's a multiple user in your session, you actually have to subscribe for each user if you want to record them their video. So one user has one video path. Once you subscribe, you will have the video stream in your callback function. So if you want to record multiple user, you have to subscribe for multiple times. So then your code will process the raw data. Once you're done, you can call unsubscribe from the video path from a certain user. That means you tell the SDK stop feeding me the raw data. So yeah, in this demo, we see how do we get the raw data. Let's summarize the steps of that. So first one is to create a class and implement the delegate interface. Then subscribe a video path from a user. If you have multiple user, you need to subscribe from multiple user. So the third one is get frames from the callback function. Then once you have the frames, you can process the video frame with your own code. Then everything done, you unsubscribe from the video path of each user. The getting raw data is actually quite straightforward, but there's always question being asked by our developers. One of the example is to calculate the PTS, presenting timestamp. So the PTS is a concept in video encoding. We need to tell for each frame what time to display, but we don't have this information in the raw data. But because the raw data is fed in real time, so we can actually calculate it in our code. So in my code, when I encode my frame into a video file, I have taken the current time as a timestamp. Now here, the start time is actually the timestamp for the first frame. I use current time minus start time is actually get the duration of current frame from the first frame. Below here, there's a video stream time-based then and video stream time-based number. This is the actual way in the video encoding to express the time unit. So with this formula, use the duration times with the video base 10 and divide by video dense number and times 1000 is actually you will get the PTS. This is a formula for you to calculate the PTS for encoding the video. So you may wish to take notes and use this formula in your application. All right, just now we have seen a very basic use case. Now let's do something more interesting. Let me show you on the demo screen again. Getting raw data is actually quite straightforward, but there's always developer asking questions. One of the example is to calculate the presenting timestamp or PTS. So PTS is a concept in video encoding. We need to tell each frame what time to display. So we don't have this information in our raw data, but because the raw data is fed in real time, we can calculate it by ourselves. So when I encode my frame into the video file, I use this way to get the PTS. First, I take the current time as a timestamp, and then use the current time to minus start time. Start time is the timestamp for first frame. When I get in the first frame, I take down the start time in variables. So current time minus start time is the duration between the current frame to the first frame. So here is the video stream time-based then and video stream time-based number. These two parameters actually is the way how does the video encoding system to express time unit. So with this formula, actually you can calculate the presenting timestamp in your code. And you may wish to note it down this formula and use your own code. Just now we have a demo about a very basic use case for recording video. And now let's do something more interesting. I will show you another demo in our demo screen. Back to our demo screen, let me switch to another code. This is another IDE because this demo I will be building an application with GUI. So I use Qt to make this application. So in Qt, if I need to receive the raw data, it's actually doing the same process as we have done in just now the command application. So we need to implement a class, and we need to create a class and implement a certain API named iZoom Video SDK raw data pipe delegate. So there will be two callback function received here. So let me look into the detail of the function. Here in the raw data frame received, we got the raw data. There's a parameter included as well as the frame buffer we received from the parameter. And then I pass the frame buffer into a function I created for detecting objects. So it's called object detection target object. So let me look into the detail to see what I do. Actually, in this demo, I'm going to use OpenCV, the Open Computer Vision, to detect an object. So OpenCV have a class named Cascade Classifier, which actually allow you to use a pre-trained machine learning data model to detect certain objects. Here, I input a pre-trained machine learning data set for detecting a banana. So this one is called banana classifier XML, which is a pre-trained data model. In the target objects function, you can actually see I convert input frame buffer into a format named matrix. So there are two matrices being converted. One is YUV and another one is gray. So you may ask, why do I need two matrices and in different format? This is a very tricky question. I will answer you after my demo, but this one is very important. Then once I have the matrix of both YOV and gray, I use it to detecting objects. So just now we already have the objects from OpenCV Cascade, and also it have a function named detect multiscale. I input the gray matrix, and the results is actually array of coordinations of all intents being detected in the frame image. So in my case, the results means all bananas been detected from the video frame. And once I detect the objects, I will target the objects on the screen. I draw a rectangle around the area being detected with a banana, and also put a name here. Here in my case is banana. I put a text name on the screen to tell this is a banana. All right, is the most important part to detecting the objects with OpenCV. Let me run application to see what does this look like. I'm still in the video session, so the application will join as another participant, then receive the raw data just now with the interface being implemented. So the video now is being copied into the new screen and displayed on the GUI. So now let me bring in some banana. Here you see in my video, I'm holding a banana picture. So once the picture showing on the screen, you have seen the banana been tagged and also been, the banana been detected and also been tagged with a rectangle and a name. So everything happens in real time. So like this means you can actually integrate your component, whatever for mixed reality, machine learning, augmented reality, or even metaverse. So this is a way for you to integrate a Zoom Video SDK or a Meeting SDK into your component. All right. Yeah, just now in the demo screen, we have seen the application detect objects with machine learning. So the Qt GUI app is built for this demo, and I use the Video SDK as well. So you can still remember, I think you can still remember the steps of getting raw data, as well as I use the OpenCV to detect objects. There's a class named the Cascade Classifier from OpenCV, which is the one to detecting with the pre-trained data model for detecting objects. And then once we're done, once we found the objects, I draw a rectangle over the objects and give a name to target object. Yeah, okay, let's talk about the interesting topic in this demo. Just now, I mentioned we actually convert the frame buffer into a matrix, which is the format for OpenCV to process the image. But you have seen I created two matrices. One is YUV and another one is gray. And what is YUV? YUV is actually a raw data format in the video processing. So the Zoom SDK actually output the raw data in this format. So there are three parts in the YOV format. Y is actually the grayscale bitmap of brightness data. So U is a blue color projection. So V is red color projection. They work together to express a color image. So in the raw data frame, you can see on the screen there's a demo. So the top 1/3 of the matrix of the frame is Y. So the bottom 1/3 is U plus V. So the full frame of a YUV data, actually the data we used for Zoom's API feeding you with the raw data is actually a big matrix, include YUV3 parts. So the size of the frame is actually 1.5 times of actual images resolution, because the Y is already a full resolution of the image, but just no color is the brightest information. And another 1/3 of the frame include both U and V. So here in my code, if you want to have a YUV matrix, I have to take the image buffer, convert it into the matrix with the size of 1.5 times height. Here I use height to divide by 2 and times 3 means 1.5 times of the height. Then with the actual width is actually enlarge the frame of my video frame, but included the U and V data. So in this way, I can calculate into the YUV matrix. But actually, for detecting objects, we don't really need a color image. If I only take the exact size of the frame height and frame width, is actually take the upper part, upper 2/3 of the full matrix, which is only the Y. Means I can use Y as a picture of a grayscale of the frame, the frame buffer. So we can ignore the U and V. So if the Y as a image is actually a grayscale image of the actual frame image. So I created a gray matrix for me to processing the object detection. So in your application, you can decide if you want to use a full YUV format or only the upper part of the YUV, which is a grayscale. So it's up to your application. But understand of how does the raw data expressed in the YUV format will helps you make sure you're doing the calculation properly. So this is a very important knowledge for you to get a proper image. So take note and use it in your application. Cool. Now you may already start to think about if your application can use raw data. It's about the availability of the raw data in SDKs you are using. Actually, Zoom has two major SDK product line. One is the meeting SDK, another one is the video SDK. So in each product line, we have three platforms to cover, three major platforms to cover: desktop, mobile, and web. On desktop, you will have Windows C++, macOS, Electron, and Windows C# SDK, but only the Windows C++, macOS, and Electron has raw data. The Windows C# currently, at the moment, we don't have raw data support yet. Video SDK, we have Windows C++ and the newly announced the C++ on the Zootopia keynote we just announced. So it will be GA soon. So you will have access to the raw data from Linux C++ SDK as well. So as well, for the macOS, you will have a Zoom raw data API to be supported. And unfortunately, for C# Electron, for video SDK, currently we don't have raw data to be supported. Mobile, for Android and iOS, you will have raw data on video SDK. The same on Android and iOS, you also have the raw data in video SDK. Currently, we don't have support at the moment for Ionic, React Native, so you cannot access raw data in these two platforms. Web, unfortunately, at the moment, for across all addition of SDK on web, we don't have raw data support. All right, this is everything in our session today. So let's wrap up for what we have learned today. So using raw data from Zoom SDK, there are a few steps you have to take note. First one is implement the dedicated interface, then subscribe users video pipeline. If you have multiple users, you have to subscribe multiple times in case you want all the video from each user. Then you can get a frame from the callback function. Once you get a frame, you can process the video frame with your own code. Once you're done, don't forget to unsubscribe from the user's video pipeline. There are a few questions interesting questions in the processing of raw data being frequently asked. First one is about how to calculate the PTS, especially in the case you use third-party components. For example, FFmpeg, you may need to calculate the PTS for encoding a video file. So today we introduce a formula of how do you calculate the PTS. So after the class, you can download the demo code and to get the formula. Another interesting topic is about the YOV matrix just now we introduced, which is actually 1.5 times tall of a frame. So you do need to be noted that is if you want to YOV matrix, you need to take extra space from the stream buffer, from the frame buffer. But actually, up to different application, you may not need a full frame of a YOV. You can only take a certain part. For example, the top 2/3 of the matrix for a grayscale image. When I in our demo to detecting objects, I just took a grayscale image. So without getting all data from YOV matrix, is really up to your application. So platform availability. So currently we have native platform support. So on Windows C++, Linux C++, macOS, iOS, Android, you will all receive the raw data support. But we don't have support on the web, nor C#, Ionic, etc. at the moment. Yeah, after the class, we hope you can download sample code and handout research to look into all the details, as well build your own application with raw data. Today, we already announced the Linux Video SDK, so you can use a Linux SDK to work with raw data. It is a good way for you to scale out your location with clouds and containers. Yeah, all right. Hope you have enjoyed the session today. Thank you and see you soon.